Hello, my name is Pat Cashman, and today I would like to talk about horse fence. Nobody ever needed or want a horse fence. What people want is a safe environment for their horse. And this is the 21st century, and things have come a long way from barbed wire, woven wire, and all the things we've used for the last several decades or 100 years. I guess we'll jump right on in to the 21st century. High tensile wire has replaced woven wire for animal containment, both cattle and horses. The situation with a horse over other animals, a horse's defense mechanism is flight. And once they start running with a high tensile fence, if it's installed properly, they get into it, and then the first reaction once they find they've been stopped is to pull back. And at that point, it'll fillet right to the bone. A couple decades or 30 years ago, Mr. Robbins out of Muscle Shoals, Alabama, who was in the vinyl business, invented a concept called poly-coated vinyl high tensile fence. Basically, it has all the protection capability, and when a horse gets into it, they can slide back out because of the vinyl coating on it. He even went a step further. If you want to use electricity to keep the horse off, he's put in a carbon core that will bring the power from the wire out to the outside of the fence, and that is basically the 21st century version of a high tensile or a wire fence. For the cosmetics, if you want the look of a board fence, they've also produced a high tensile wire, 3 strands, and from a distance looking at it, once it's installed properly again, it looks like a board fence with significantly less maintenance. The painting of it on a regular basis, splintered boards, and it's just a much safer, easier, and a much durable product. I mentioned electricity. If you're going to use electricity again, copper is much more effective than galvanized wire, stainless steel wire, or any other type of material. Now we have a product that is a high-strength poly fiber that has the strength of high tensile wire. High tensile wire has a breaking strength of approximately 1,350 pounds. The high-strength poly fiber with the copper woven in it has a breaking strength of over 4,000 or 5,000 pounds. Not only that, the copper itself is woven into the fiber, and you're never pulling against the copper, which is a soft wire, and it won't break or pull, versus the stranded wire that's got stainless steel wire in it, and if a horse hits it, it will break, or if a cow hits it, it'll break, and then you've lost the continuity of the wire. The other thing, the high-strength poly fiber has got enough UV inhibitor and will guarantee it for 25 years, as compared to the other types of vinyl that have less UV inhibitor and will break down over a short period of time, 3 to 5 years in a permanent installation, just with the sun, the weather, and they become brittle and just crumble. So this is, if you're going to use electricity, is the safest, it's the easiest to install, and instead of with any other type of fence, your fence posts being 12 to 16 feet apart, on level ground you can go up to 100 feet. 50 is very normal, just as long as you stay with the contour of the ground. And installation cost is the least expensive of any product we've got, and the easiest to put up, and then going back to our number one concept, it's the safest. Once an animal touches it, maintaining a 5,000 volts of electricity, they won't touch it again, and they can feel it 15, 18 inches away through their muzzle, and if you leave it on all the time, animals will not touch it. It's effectively been used by the U.S. military around airfields to keep deer, elk, and moose off of the runways. and it's proven to be the most efficient system that they've come up with. To explain a little bit more about copper, let's compare it back to your house. Would you even think about wiring your house with galvanized wire? Obviously not. And if you're using copper, you don't mix aluminum or any other type of wire in your fuse box at home, in your paneling, or anything you do. The copper has to be consistent through the entire program, starting with the ground rod. You go to most farm stores and they sell a 3-foot galvanized rod that you pound in the ground. It's literally impossible to get an efficient ground. You need a minimum of a 6-foot copper-clad rod. And you need a minimum of 3 rods spaced 10 feet apart, wired in a series into your energizer. And a copper lead-out wire leading from the ground rods to the energizer. The energizers typically are listed in mileage or acres, from 10 mile, 20 mile, 50 mile. This is an unregulated industry, and unfortunately everybody lies. If it says 50 mile, discount 90%, it's good for 5. Look on the fine print on your energizer and it'll tell you the joule output. It takes 1 joule of energy per mile of fence to maintain 5,000 volts, and that will keep the animal off the fence. So you've grounded copper wire to your energizer, then from the energizer back to the fence, the copper wire, and then with a copper split bolt, you energize the fence. And that's the most efficient way to get enough voltage on the fence to keep animals off of it. Later on in this video, we'll show you an installation with fence posts 100 feet apart that was put in 8 to 9 years ago. The fence is in as good a shape today as it was 8 or 9 years when we installed it. And to my knowledge, there hasn't been a deer, a coyote, or a dog come in that field, or an animal get out of that field in 8 years, both horses and cattle. The simplicity of installing the high-strength polyfiber fence is keep it simple. We're using a roller insulator at the ends where we terminate, and we pull it with a tensioning tool to pull it. You pull it by hand to start with and put the split bolt on it. Then we have a tensioning tool, which is like a mini block and tackle that we tie to the brace post and pull it with this tail, pull it tight. After an initial installation, you'll pull it about 2% with the tensioning tool. So if you've got 1,000 feet of fence, you're going to pull it 20 feet. Let the fence stand for 2 to 3 days and go back and retension it, and you'll pull it another 1%. The simplest thing are line post insulators. This is as simple as it gets. If you have to anytime, you can loosen it and it slips right in. There's decorative type, which we don't recommend because of the sharp edges. They look cute. It's a little horse's head, but it's got sharp edges, and if a horse does get close to it, there's too much danger of being. This is a clamshell, which is also a very efficient way, and it is smooth edges and all that. And again, the roller insulator at the other termination end. Again, copper split bolts that hold the wire together, or the high strength polyfiber and copper, and then you also run the insulated copper wire to this from your energizer or to the ground. Again, here is a corner installation in the 20-acre field that we talked about earlier. We're bracing the corner post again from both directions. The corner post is a 9-foot post, 6-inch in diameter. We're 4.5 in the ground, 4.5 above. The brace wire is 22 degrees or less. So we're bracing from the bottom of the post to the top there and pushing this post into the ground. At 4.5 feet above, it's just pure physics. 2.5 times that, we need to be 10 feet out. to maintain that. If not, it's going to heave. So we're 12 feet in this case instead of 10, but it's just as long as we're over the 10. And this is a standard corner brace. So we're bracing from this direction and again bracing from the other direction. We put a roller insulator on the inside, but in this case we're going around the outside with 2 of the roller insulators instead of this being pulled out if the screws would happen to loosen or become fatigue or whatever. It's much more secure going around. We're pulling against the outside of the post because we're pushing the post into the ground. Here's another example. When we tell people you can put 100 feet between posts, they kind of look at you like you're telling them a story of some kind. This again has been up for 8 to 9 years and we're 100 feet between the fence posts. The other thing, the fence posts are 4-inch line posts, which are about the same cost as a metal T-post. And there's no comparison in the safety value. We have had horses and cattle for 50 years on this piece of property, and we'll never use another T-post ever. We've had them with horses stuck in their chest. We had a little heifer one year that rubbed on the top of it and rubbed it clear up through her jaw, and then we doctored her for months before we finally just gave up on her. Here's another point on the ground rod. We're energizing the top and the 2 bottom strands. We're grounding the middle, or one from the top. This is again, split bolt, copper lead out wire, and you can't see the end of it, but we're 6 feet in the ground with a copper clad ground rod here. A lot of people will just run this and or plug it into any old type of cheaper wire or anything else. Electricity in your fuse box in a outlet at home has to be positive and negative. If you don't have the ground, the positive won't come in, or if you have a weak ground and have enough power on the positive, it'll bleed down and both of them will be energized. You have to use the same strength copper in the ground rod with a copper lead out wire and a ground rod. This is the wettest spot of the field here. So July and August, when the ground is real dry, if an animal doesn't get grounded through their hooves, they touch 2 of these and they're going to get the full jolt. In this case, we're running 9,000 volts of electricity through this wire. And if, for instance, if a deer were to try to jump this and we're in flight and not touching the ground, hopefully it would be repelled to the other side and not get in the field, or you've got another problem, how to get the deer back out of the field. But again, the copper lead out wire, and on a fence like this, we probably have 2 ground rods just grounding the ground. Sometimes when people tell us that they're not getting enough power through the line or whatever, well, you find out their brother-in-law, the electrician, installed it, and most electricians don't understand that you don't ground through the circuit, you ground through the animal's feet. And that becomes a problem if they don't understand that concept. But here again, showing you the ground in the middle of the field, along with we're still grounded at the energizer and all the way through the system. Here's an example of splicing or repairing a fence. In this case, it wasn't repaired. This is a 1,000-foot spool of fiber, and we joined the 2 here. It's 2 split bolts, and again, they wrap the ends of it here so it doesn't fray. Burn it and then wrap it. Here's a case where a little bit longer splice, and they put the zip ties on it. And again, I don't want to touch it, but there's again 9,000 volts. When you come to an end, you burn it just like you would any other fiber twisted rope, and then put the tape on it and then burn it with a match, and then it doesn't fray out. But again, this is a way you would splice after joining 2 rolls together. We recommend not going over 2 rolls or 2,000 feet, and then we terminate it. And I'll show you that at the next termination post. But for instance, if a tree would fall on this, which has happened, and the fence will go down to the ground, shut the electricity off, cut the tree off, and the memory will bring it back to its original position without. If for by chance something with a sharp edge would sever the wire or the fiber, you just put 2 pieces together, splice it together like this, and then go back to the termination end and retighten it as far as repairing it. I don't know of any fence we sell that's any easier to splice or to repair a damage with a tree falling on it or any other thing that would cause disruption in the braid itself. While we're at this point in the fence, we've got a swale that goes through the field, and we put the posts closer together. You can see they're 100 feet apart on down, and here we put them probably 50 feet apart to stay with the contour of the ground. So it's the most flexible installation of any fence product that we sell. Here's a case where we've taken 3,700 feet around the fence, so we're halfway at this point. We terminated the fence at this point with a roller insulator. Obviously, we tightened it to the direction there, and we've tightened it to the other direction. We're jumping around the post. Here's the copper split bolt. We're jumping around the outside of the post with the copper lead-out wire back to the other side. So the continuity is consistent throughout the entire fence. We're maintaining 9,000 volts from the starting point of the fence to every point on the fence, which this is the furthest point where we terminated and jumped to the other strand. 2 rolls go in the other direction. So it's a really simple installation. We also grounded the ground rod, which we talked about earlier. We jumped around the post with the ground rod to maintain the same continuity between the ground and the positive, so that if they don't get grounded through their hooves. For instance, we've had cattle and horses in this field, and if we had sheep, we would have, instead of grounding this one, we would have grounded one from the bottom. A lot of people say that sheep, because of the insulation with their wool, are not affected by electricity. That's not the case. They can get full energy through the wool. It's their feet are so small that on dry ground, they don't get the full jolt of that. So here, if it's sheep or hogs, they're going to get grounded here. A hog will not root under this fence. So I don't know any other fence that a hog won't root under. This year, we're taking a hay crop off of this field, and we don't have animals in it. We have had horses and we have had cattle. About 4 or 5 years ago, we had a dozen cows and a young bull pasture breeding, and an old bull got out of the barn. Somebody left a gate open one night. Now, the old bull in the year and a half before then has walked through every fence on the property. 3-board, 4-board, galvanized hot wire. He just walked up to it, 2,200-pound bull, and walked through the fence. We found him the next morning. He had circled this 3,700 feet of fence. The ground was all tore up on the outside, but he would not cross the fence itself, which is one heck of a testimonial for a 2,200-pound bull that's literally walked through every fence on the property. Here we've been talking about poly fence. The poly fence that's around the world, the original versions were basically invented and developed in New Zealand for pasture rotation, for temporary fence where they rotated the pastures to maximize the efficiency of grazing sheep. A lot of them have come to this country and misinterpreted it, we feel. It is never designed for perimeter or permanent type fence. There was another poly fence that was originally developed in Europe, and it's high strength polyfiber, and it's the only one that's using copper wire. Currently, there are several manufacturers in Europe, Canada, United States that are making copper wire in high strength polyfiber. We have come up with our own private label now that's called, we're calling it Cashman's Elite Fence System. It's a fencing system. You have to use all copper, we talked about before, from the ground rods to the lead out wire to the energizer to the fence itself. Our version now has more copper than any other fence, any other high strength polyfiber fence. It has 6 strands of copper wire, and the breaking strength of over 1,700 pound compared to high tensile wire breaking strength of 1,350 pound. So it comes in a 1,000-foot roll, and we have it available at a very, very competitive price. Here we've talked about confinement for the animal to keep it on your property, off the neighbor's property. Traditionally, we're building a board fence, or we talked about the high-strength polyfiber and all the other different options in fence. To build a round pen for a small area to break the horse, and even to a controlled environment of 60, 70 feet, once the horse is broke, so it's not running off, and in a training process, a round pen is the most viable. To build a round pen out of permanent fence is definitely an option, and we'll talk about that. Or you can put out of temporary panels, which are more portable, versatile. Here's a 100 by 200 arena. You can see on the other side the round pen set up and individual panels, and there's advantages and disadvantages to everything. Basically, if you build a round pen out of a fence, you've got a permanent structure. You can't move it. If high maintenance and no residual value. If you decide you want to sell the horse, sell the property, and move on, you've got a pile of scrap at most. On portable panels, you've got total versatility. They're easy to put up, and cost-wise, they're not that much more than a permanent fence. And they carry residual value that you can sell them. You can keep on moving them around the property. They're great as far as not only a training mechanism and a safe environment. You can have a horse, you just want to get him out of the barn. The pastures are wet, soft. You don't want to tear the field up, so you put him in a round pen and you don't destroy your pasture. Basically, there are two types of panels. The rounded corner, which has been on the market for 50 years, or currently we have the horse safe, where the horse comes all the way up. You can't get a hoof caught. For instance, if these two panels were joined together, you've got a valley here that if a horse rears up and get a horse caught, and you're in serious trouble if he's stuck there and you try to get him out. Where the horse safe is just eliminated that entire scenario. Then we have different pinning mechanisms. A drop pin, which has been on the market for years. It hooks the panels together. Here we have what a P hook, again, that connects the panels. There's a chain mechanism that wraps around the panel and then hooks. The chain was primarily designed for the cattle industry, where you're hooking 2 or 4 panels together rather than just 3 or 4 or 5. And you hook them together. The problem with just hooking 2 panels, you can't really get them tight. So it's always going to be a loose connection and loose fitting. This is what we call a rodeo latch that is the safest of any system going. If you take anybody's panels, when they get into their premium line or their heavy duty, this is the most popular latch or pinning system that you will find. Then we go through, there's all different varieties. 5 foot tall is definitely the most popular. We do carry 6 foot in a number of different series if you feel you have to have a 6 foot panel, but over the last decade or so, we sell very few 6 footers. It's very difficult for even your best jumpers to get enough of a start in a round pen to jump a 5 foot fence. Then we go, the industry is based on gauge of pipe. Everybody talks gauges. I personally don't know of a single company that will put their name on a panel and put the gauge on it. It's an unregulated industry, and there's a lot of people talk heavy gauges and this and that. The best way to judge steel sells by the gauge or also by the pound. You can take the economy panels and they're going to weigh in at 35, 38, 40 pound. You get into the heavier panels, you're up to 65 to 75 pound. The best way is to go and physically look at a panel. You can't tell it on the internet, you can't tell it on what people talk about. on Craigslist, on used panels or anything, just lift the panel. On the lighter weight ones, when they bend it, the tube crimps. On the heavier ones, it's smooth on the inside, on the corral panel. So you can tell the weight of the panel. This, for instance, here's a panel that is a horse safe. Here's another one and another one. They look the same, they're completely interchangeable. But here's a 70-pound panel. Here's, we call our Cashman horse panel. Here is a heavier panel, it's our heavy horse, and it's going to weigh another 10 pounds heavier. Then we have a Super Duty panel that's heavy enough to hold rodeo bulls, and this panel is going to weigh 120, 125 pounds. It's overkill for an equine horse operation. Our most popular is our Cashman horse that is heavy enough to hold up. And the other thing with a horse, a round pen or a panel is more of a visual barrier than a true physical barrier. A cow is going to come up and push on it, lean against it, or even just charge into it. A horse is going to look at it and stay within the area without physically coming in contact in the majority of cases. This is a heavy weight if it's commercial, if they're pinning calves, using them every day. And we sell this panel to a lot of commercial operations, but even on those, they damage more of them moving them with the forklift or a tractor than they do from the actual animals touching them. Then you get to the finish. These are standard painted panels. The newer processes are powder coat, e-coat, where there's no volatiles escape into the environment. And it also gives you a nicer finish. Here is the same panel in our Cashman heavy horse that's got a powder coat finish on it. To get this finish to really hold up and not peel off is a very expensive process. They clean the pipe first of all with 400-degree chemical, and it has to have, you can't have any seams or holes anywhere in the weld. If not, moisture will get in, and when they heat it to 400 degrees, it'll actually blow that tube apart. We also carry it in hot dip. There's a lot of galvanized panels on the market. Very, very few hot dip. For instance, our economy panel over here is not only lightweight, it's galvanized, and when they weld this joint here, the flux in the weld interacts with the zinc on the metal, and this joint is going to rust out or fatigue much more rapidly than just a painted panel. Where if you hot dip, they drill holes in the top and the bottom of every piece of pipe, and then this entire panel is immersed into hot zinc. A panel, our heavy horse panel, weighs about 70 pounds. By the time they hot dip it, it increases the weight by 13 pounds. There's zinc on the inside and on the outside, and it increases the cost significantly. But again, here's a panel that's going to look like this with no rust 25, 30 years from now. That's the gist of our panels. We also carry the largest selection, the largest inventory of anybody in the entire United States. You can come to our facility and you can look at the inventory here and find the most complete selection of anywhere in the country.
Fencing your animals is no longer the back-breaking work it used to be. With ElectroBraid fence, you can start right after breakfast and have this 1-acre paddock completely fenced before supper's on the table. Now that's fast. That's simple. ElectroBraid is so simple that except for digging post holes, the only tools you'll need to install the braid fence can be carried in a canvas tool bag. ElectroBraid fence is the permanent electric fence which is safe, secure, simple. Installing ElectroBraid will save you time, money, trees, and trouble. This installation video will explain how to install ElectroBraid for small paddocks, medium pastures, and large pastures. Proper size paddocks and pastures are important for the care and well-being of your animals. Fights are bound to happen with overcrowding. The larger the paddock, the less stress and the less chance of a horse getting hurt. 100 feet by 100 feet should be the minimum size paddock for 1 or 2 horses. Pasture should be at least 2 acres per horse, with no obstructions which could hurt a horse, and no sharp corners where a horse can get trapped by another horse. A proper sized paddock or pasture fenced with ElectroBraid, well, you're going to have happy horses.
Start by setting your corner posts and end posts.
ElectroBraid is a tension system. That means you should brace corner posts according to the contour of the land and soil conditions. Whether you choose H-bracing or H-bracing with a 4-board look, a rounded corner system, or the mule corner post and anchor system, correct bracing will be the backbone to your ElectroBraid fence. The mule is a pretty slick posting system and works well with ElectroBraid. The mule uses augers as an anchoring system. Use a large auger for corner posts and brace posts, the small auger for dip posts. Just screw in an auger for a fiberglass corner post. Then screw in the brace augers at 45-degree angles. Bolt the brace post to the corner posts and screw on the insulators. That's it. It takes no time at all to install, and it's not coming out. Now, with the posts in place, use a jig or ruler and mark the posts for spacing each line of braid. Space the other 3 lines a foot apart or to whatever spacing best suits your animals. If smaller animals are fenced with larger animals, simply widen all the spacing an equal amount in order to narrow the space between the bottom braid and the ground. If you have predators, such as coyote, wolf, cat, or bear, an extra line of braid may help to keep them away from your horses.
Now, center the insulators on your marks. Use 2.5-inch screws to attach the insulator to the fence post. You can also use a flexible webbing option. If you're using the webbing, drive a stainless steel nail through the top hole to hold the insulator in place. Don't anchor it solid. This nail is temporary.
Measure out and cut lengths of webbing to overlap around the posts. Slip the webbing through the insulator and strap the insulator to the post. Secure the strap with 2 stainless steel nails and washers. Remove the nail which was holding the insulator in place. Strapping allows the insulator to freely adjust to the directional changes of the braid. Installing the braid is simple. Using the end straight from the reel, thread the braid through the insulator and clamp it tight. Leave approximately 2 inches outside the split bolt connector. Make sure the connector is tight to avoid slippage. Now, start fencing. Carry the reel with you. On a small paddock, fencing with ElectroBraid is as easy as walking the perimeter of your paddock or field.
At the next corner post, remove the pin lock and roller and slip the braid behind the roller. Replace the pin lock and you're on your way to the next post. Do the same thing at all of the corner posts and watch how easy the braid changes direction. It travels freely around the roller. This first strand of braid between all of the corner posts is a guide that tells you where to dig your inline posts. Using your guide, Start digging and install your inline posts.
There won't be as many posts as on a traditional fence. Inline posts are only needed every 50 feet. However, depending on the lay of the land and climate conditions, you can span up to 100 feet. That's 1/10 the number of posts for a traditional fence. ElectroBraid's super strength and tremendous resilience allows for these distances. At the end post, pull out as much slack as you can by hand. To tighten the fence further, you'll need to use the ElectroBraid tensioning kit. It's easy to assemble. Tie the S-hook to one end of the ratchet rope. Insert the other end of the ratchet rope into the ratchet. Insert the rope opposite to the release switch around the ratchet wheel and back out in the opposite direction. Tie a knot to prevent the end of the rope from slipping back through the ratchet, and you're done. Attach the ratchet system to the post. Now, tighten the braid with the ratchet system. Keep going. Tighten until the ratchet won't pull any tighter. Depending on how much slack you pulled out by hand, you may have to repeat this tightening process several times. Now, clamp the line with a split bolt connector. Leave approximately 2 inches of braid outside the clamp. Then tape, cut, and singe the end. Always tape before you cut. It prevents fraying. Singeing prevents fraying after the tape wears off. Return to the beginning post and attach the ratchet system and tension the braid. Release the split bolt connector. Take out the slack and retighten the bolt. That's all there is to it. Install the remaining lines in the same way. In different soils and in different climates, posts can shift and cause the braid to relax. All you have to do is simply reset and tamp your posts and retension the braid. Be sure to tighten each line before starting the next. ElectroBraid allows you to work with the lay of the land. Streams are easy to cross. ElectroBraid accommodates all sorts of terrain, including dips and rises. You can use wooden or fiberglass inline posts. The fiberglass posts are lightweight, sturdy, and using the dip auger for anchoring, they're easy to install. And once in place, a mule can't pull them out. ElectroBraid is ideal for wooded environments. Trees can be used as corner posts, inline posts, and as end posts. Installing ElectroBraid on medium-sized pasture is every bit as easy. Because of the longer run in a medium-sized pasture, you need to tighten the line from corner post to corner post. You'll need a second ratchet system to do this. After installing a single line of braid and clamping the braid at the end post or gate post, go to the first corner post and tighten the line. Pull out the slack, then tighten the line with the ratchet system. Leave the ratchet and clamp attached to hold the line tight. Proceed to the second corner post and repeat the tightening process with a second set of ratchet and clamps. Leave them attached to hold this section of line tight. Return to the first corner post. Remove the ratchet and clamp and use it to tighten the braid at the third corner post. You're simply working your way around the paddock and tightening at each corner post. Using this method on long stretches allows you to tighten each line in one procedure. Installing ElectroBraid on large pastures is pretty simple too. For large installations, you can run 4 lines at once. Here's how. Set brace posts every 2,400 feet. Space inline posts every 50 to 100 feet, depending on the lay of the land and climate conditions. Attach 4 lines of braid to the first brace post. Run the lines for 2,400 feet to the next brace post. That's 2 full reels of braid. Install the braid to the insulators on the inline posts as you go. Splicing together reels of braid is simple too. Use 2 split bolt connectors and make sure the double helix copper connects with the split bolts. Tighten the bolts, and away you go. Tighten and terminate all 4 lines at the brace post. Attach 4 more lines of braid and use jumper cables for an electrical connection. Simple, isn't it? You're going to repeat this procedure from brace post to brace post. When you get to a corner post, insert the braid in the insulator. Pull out the slack by hand, then tighten the braid, leaving the ratchet system attached to hold the lines tight. Remember, tighten at corner posts. Tighten, clamp, and terminate at inline brace posts. Continue running the braid in this way until you reach the end post or gate post. All you have to do now is add a gate. Choose your gate carefully. Ideally, a gate should be hung so it swings both ways, allowing for the gate to always swing in the direction you're leading the horse. Whether it's a geotech gate or any other quality gate, you now have a physical and psychological barrier for your animals which is safe, secure, simple. And with regular inspections and minimum maintenance, it will stay that way for many years to come. ElectroBraid's strength, durability, and resiliency makes it the perfect barrier for year-round fencing. Add to that its ease of installation, and you have the future of electrified fencing. Installing an ElectroBraid fence is a sure sign you care about your animals. Here's a few tips for keeping them safe and secure. Test your fence at the highest and driest points of the fence. Test at the furthest point from your ground system, and test your fence often, making sure that you have 5,000 volts at all locations. Always introduce new horses to your herd gradually to minimize fights as they sort out the pecking order. Always introduce your animals to the ElectroBraid fence before you turn them loose to enjoy their paddock for the first time. Don't mix mares with geldings and stallions. Always separate mares from geldings and stallions in separate paddocks. Always buy the proper fence charger for your application and follow the manufacturer's instructions that come with it. Make sure if a post shifts, you reset it, tamp, and retighten the braid. And it's always a good idea never to turn off the electricity to your ElectroBraid fence unless you're working on it and the horses are not left unattended. It's very important to test your fence at the highest and driest points of the fence. Test your fence to the soil at the furthest point from your ground system, and test your fence often, making sure you have 5,000 volts at all locations. With proper installation, regular inspections, and proper electrification, your animals will be happier behind your ElectroBraid fence. ElectroBraid works well, costs less, looks great. Visit our website or give us a call. Your horse will only respect your ElectroBraid fence if it's properly electrified. Electrifying your fence starts with a good grounding system. Use a minimum of 3 copper-clad ground rods. Do not remove the clamp on top of the ground rod. Leave the clamp on while pounding the ground rods into the earth. Pound 3 copper-clad ground rods into damp, moist soil in a dip, glade, or other low-lying wetland. The 3 ground rods should be spaced a minimum of 10 feet apart in a rough triangular pattern. Doing this will ensure a proper ground system. Now, grab a shovel. Dig a shallow trench approximately 8 inches deep. Always bury the wires to protect them from damage and to protect you and the horse from tripping. Connect all 3 ground rods using a continuous length of heavy insulated copper lead-out wire. Strip the wire and then fold the strip section in half. This double copper strip will ensure a good connection with the copper on the ground rod. Connect the ground wire to the ground rod and tighten the clamps. It is best to use a continuous length of ground wire. Do not use 3 separate wires to connect the ground rods. Still using the same length of ground wire, string it all the way back to the Energizer, making sure to bury it 8 inches deep. Your ground system is now ready to be connected to the Energizer. Just use a little common sense when you're choosing where to put the Energizer. The closer it is to the fence, the less wire you need to use, and the less trench digging you'll need to do. Also, place it out of the weather, away from flammable materials, and out of the reach of children. The ground wire you just connected to the ground rods now gets attached to the Energizer. Then connect a length of lead-out wire to the Energizer. String this lead-out wire all the way out to where it'll connect to the fence. Make sure you bury the wire to protect it from damage.
In rocky soils, it's best to run the wire through a poly pipe to protect it from any abrasion.
Where the lead-out wire meets the fence, fasten the wire securely to the post to protect it from the horses or any other kind of damage. Connect the lead-out wire to the top strand of braid with a split bolt connector. Then, using short lengths of lead-out wire, jump down from the top strand to the third from the top. And then, jump from the third from the top to the bottom strand. Grab that shovel or pick again, because you're digging a trench to the nearest ground rod in the grounding system we attached to the Energizer earlier. You'll be running a length of wire from the second from the top line directly to your nearest ground rod. Connect the ground wire at one end to the ground rod and attach the other end of the ground wire to the second from the top line. You will also have to wire all gates as well. Please consult your installation manual to see exactly how this is done. The electrical connections are done. You can go plug in the Energizer. It's time to test the fence. To see if your fence is properly electrified, perform the following tests. Go to the furthest point of your fence from the ground system. Test the second from the top grounded line and each of the other electrified fence lines to confirm that the fence is wired properly with no electrical shorts. The voltmeter should read at least 5,000 volts. The next test is the most important test. Check the voltage between each electrified fence line and the soil under the fence. Place the ground pin on the voltmeter about half an inch into the soil and test the actual voltage of each positive line. The voltmeter should read at least 5,000 volts. Repeat this test to the soil at any high points or dry areas in the paddock to make sure that you're getting at least 5,000 volts. If all readings are over 5,000 volts, your fence is working properly. If you get readings below 5,000 volts, please watch the troubleshooting section of the video to diagnose the problem. Troubleshooting your fence begins back at the fence Energizer. You will perform the following test to diagnose where the problem is. First, unplug the Energizer. Disconnect the lead-out wire and the ground wire from the Energizer. Turn the fence Energizer on and read the voltage on your charger. All readings should be a minimum of 5,000 volts. If less than 5,000 volts, there's a problem with the Energizer. If the Energizer is okay, you must retest the fence. Make sure you turn your fence Energizer off before you reconnect the two lead-out wires. And make sure you plug it back in before you walk out to where the charger is connected to the fence. Walk back out to where the Energizer is connected to the fence, and using the voltmeter, test the fence. The ground pin on the voltmeter should be connected to the second from the top grounded line. The hook on the voltmeter goes on the electrified fence line. Touch the voltmeter hook to the copper on the braid for a solid electrical connection. Make sure all readings are a minimum of 5,000 volts, and test all of the lines. Any reading less than 5,000 volts means there's a problem with the lead-out wire, or you have crossed wires during installation. The next test is the most important. Check the voltage of the electrified fence line to the soil. Place the ground pin about a half inch into the soil and test each positive line of ElectroBraid. All strands should test above 5,000 volts. Repeat the same test at any high points and dry areas along your fence. If any test is below 5,000 volts, there's a problem with your earth return system, and you'll have to test your earth return system. To test your earth return system, you're testing to make sure your fence is grounded sufficiently. Turn your fence charger off. Then choose a location at least 350 feet away from the Energizer. You want to short-circuit the fence to test the ground system. Do this by laying metal stakes or pipes against only the bottom strand of the fence. Then, go back to the Energizer and turn it back on. If you have a digital voltmeter, apply the ground pin to a screwdriver placed in the ground at least 3 feet from the ground rod. Apply the voltmeter to the ground rod. The reading on the voltmeter should be 300 volts or less. If it is greater than 300 volts, you'll need more ground rods. If you have a 5-light voltmeter, you'll need to perform the following test. Before you walk back, make sure you're wearing plastic or rubber shoes, because your next step is to place one hand on a ground rod, then slowly place a finger on a blade of grass.
If you feel no tingling of electricity, place your hand firmly on the ground. If you still feel no tingling, your grounding is okay.
If you do get that electrical tingling feeling, add more ground rods. Or contact an ElectroBraid customer service technician for advice on grounding your fence. With your ElectroBraid fence properly installed and properly electrified, you'll have a fence that is safe and secure for your animals with little or no maintenance for you.
The first step after receiving all the materials for your common sense fence is to identify and become familiar with all the components. Lay out everything you've got and count all the parts against your order. Now it's time to start installing. Determine where you want your first corner or end. You will put in all the corners, ends, and changes of direction first. Set out the corner post and braces needed for this first corner or end. We'll start this demonstration with a 4-foot corner post. 5- and 6-foot corner posts need additional installation steps. We'll cover that later. Put the aluminum insert and set screws in the bottom of the corner and brace posts. Take out 9 inches of dirt and screw the anchor straight down until the top of the anchor shaft is even with ground level. Next, measure out 51 inches for a 4-foot system and stick the anchor into the ground in line with the wire run. You do not dig a hole for the brace anchors. Start the brace anchor straight down and screw it in until the flighting is just under ground level. Now pull the anchor over toward the post while screwing it into the ground. It's a good idea to check the angle of the brace when this auger is halfway in. Slide the corner post over the first shaft and hold the brace post next to the brace shaft to see where it will be on the corner post. It should meet the corner post about 7 holes or 14 inches down. The handles of the install tool should be at ground level if the angle is correct. If the angle is not correct, simply screw backwards a couple of turns and adjust the angle when you start to screw it back in. Screw in the brace anchor until the top of the shaft is just below ground level. Now dig a little dirt out from around the shaft. This allows the fiberglass tube to slide over the shaft. Repeat this process for the second brace. Slide the corner post over its anchor shaft. Align the pre-drilled hole straight down the fence line for an end post, or split the difference for a corner post or change of direction. Tighten the set screws as much as you can. Make sure the connections are below ground level. Slide the brace strap over the corner post, go down 7 holes, and fasten the brace or braces to the corner post with the bolt, washer, and nut. Now level the corner by sight or use a level. Try to lean the corner back 1/8 bubble to allow for any settling when the wires are tensioned. Once leveled correctly, tighten the set screws as much as you can on the brace posts and backfill the dirt. That's it. Here are the differences for 5- and 6-foot tall systems. First, the brace clamps need to be slipped onto the brace tubes before the aluminum inserts are installed. The measurement out for the brace anchors is 65 inches for 5-foot and 72 inches for the 6-foot. These measurements will change for all fence heights when installing a corner or end on a steep slope. Next, for attaching the brace clamp, count down 8 holes for the 5-foot and 9 holes for the 6-foot. Let's take a moment to talk about the anchors. It's important to note that the amount of torque it takes to screw the anchor into the ground is directly related to its pull-out force. As the anchor goes deeper, it should continually get harder and harder to turn. If it is getting hard to turn when the anchor shaft reaches ground level, the anchor is in good soil and will hold. The standard 6-inch auger can be used in more than 85% of all applications. If the anchor turns easily all the way down, the anchor did not get into good soil that will hold. To solve this, add a 12 or 24-inch extension and screw the auger deeper into the ground until the anchor gets more difficult to screw in. If you know the ground is loose sand, peat, or swampy, you may opt for the 10-inch auger. 10-inch augers will give you more pull-out resistance. In very hard, dry soil, get additional help for added down pressure and turning power. For very rocky conditions, a 4-inch anchor may be necessary. This is a shorter shaft with 4-inch flighting, which will allow penetration in rockier soils. Sometimes a little back and forth motion with quick snaps forward will help get by some rocks. For bedrock, a rock anchor may be necessary. Jackhammer a hole into the bedrock and cement the shaft into the rock. As you can see, every soil condition has been addressed and handled. It's important to note that if the fence is trying to push the brace anchor into the ground, if you hit a rock or other obstruction which prevents the auger from going any deeper, that is fine. The brace anchor will be under compression, pushing down into the ground, and the post will be solid. The anchor shafts are adjustable in the fiberglass posts. Basically, you need to get the corner auger down far enough to hold and the brace anchor until it will go no further. Now that all corners, ends, and changes of direction are in place, it's time to start putting up wire or ElectroBraid. Now let's look at installing ElectroBraid. Necessary tools include pliers, adjustable wrench, wire cutter, electrical tape, lighter, and the ElectroBraid tensioning kit. Let's begin. The first step is to install roller braid clips on all corners and changes of direction except for the start and ending points. Next, walk the braid to the post where you will end, inserting it in all the installed roller clips as you pass. Secure the braid to the ending post. Install the U-clip, wrap the braid around the post, and secure with a split bolt connector. Attach one end of the braid tensioning system to the starting post with the other end scissor clamped to the braid. Pull the rope on the ratchet until the ElectroBraid is as tight as you can get it. Reposition the ratchet as necessary. Once tight, put a split bolt connector on and secure the braid to the post. Wrap some electrical tape around the braid and cut through the middle of the tape. Singe both ends with the lighter. To splice the braid in the middle of a run, such as the end and start of a roll, use 2 split bolt connectors. Again, use the first line of braid to assure a straight line when driving in the line posts. Pound in the posts, put the clips on, and secure the braid. Run the rest of the ElectroBraid lines and secure them as before. Check the tension of the braid after a couple of days on longer runs. Retightening longer runs should only have to be done once.
The other thing that we do have here are several creek crossings. And the way this system is set up to keep the fence hot crossing the creeks is phenomenal, and we're extremely pleased with that.
We recommend burying a 1-inch poly tube under the gate to get electric power across the gate opening. Run the hookup wire through the poly tube. Bend the tube and put on a cable tie. It's best to hook up the top wire to the top wire and so forth, so the plus and minus wires can be changed in the system simply by changing them at the charger hookup point. Fence is up, gates hung, electrical under the gates. Now it's time to hook up the charger and ground rods. We recommend 2 to 4 ground rods 10 feet apart, connected to one another and to the negative black terminal on the charger. Improper grounding is the cause of 90% of the problems experienced with electric fences. Try to locate the ground rods in a moist area, staying away from all water supplies, underground pipes, utility ground rods, and buildings. Locate the charger as close to the fence as possible. Hook the hot wire to the positive terminal. Hook the fence ground wire and rod ground wire to the negative terminal. We recommend using the hot and ground fence polarity system. This ensures the performance of the fence regardless of earth conditions. Electric fence warning signs are a good idea and are required by law in many areas. It's best to introduce animals to new fences in small numbers. Let a few animals out for a day, and then let the rest out. The larger numbers will learn from the animals that have already introduced themselves to the fence. When you choose the common sense fence for the gentle control and protection of your valuable animals, you've chosen a true fencing system with many advantages over all other types of fencing. Mule corner posts are uniquely dependable and strong. Costly maintenance is a thing of the past. Installation is do-it-yourself simple. Safety for the animal is unmatched. And the long-term effectiveness of the common sense fence lets the system truly live up to it.
This heavily wooded area is not way out in the woods, it's the outskirts of the Little Rock Air Force Base. Even though you can't see them today, there's an estimated 400 deer living near the base. Sometimes they wander onto the runways.
Last summer, we were doing a deer count every night, and we were averaging 19 deer on the airfield every night.
Wing Flight Safety Chief Captain Jonathan Van Noord says twice in 1998, deer wandered into the paths of aircraft. Those collisions sent the Air Force looking for solutions. They found an electric rope fence.
The fence is very flexible, so if a deer runs into it, it's just going to push, and the fence will push it back.
This type of fencing was originally designed for much smaller enclosures like pastures or orchards, so the Little Rock Base's fence line is the longest known of its kind in the U.S. 270,000 feet of fence line now surround the airfield. That's more than 5 miles of rope. The fence gives off short electrical pulses, enough to give an animal a jolt, but not do any permanent harm.